today we're going to talk about is boost converter. What a boost converter is a switching. It's a switching. It just does stuff through a switch mode power supplies. It has an inductor. It has a pulsing source and has diode and capacitor. Of course, there's other variants with it doing different ways, but we're going to do it this way. There's also a charge pump, but I don't like that charge pump one because it might do better than this. The charge pump might provide out more current stuff than doing that, but they need you to have a strong transistor in order to handle it. Because we will go on that later on about what that's going to be about. Why you have to, why you can't just use any transistor in a charge pump. Where in this one here you can, because the coil I'm using has high enough resistance that it will not break the transistor. Anyway, we're gonna make what we got here. We're gonna test it out. We're first gonna test it out with this function generator. This is the function generator right here. Then we're gonna test it with the button. Now, what this gray thing is, this is the button. It's actually a keypad for its old telephone, but we're gonna use it for manually pulsing the signal through the coil. I have a 100 microfarad 50 volt capacitor here. You want to make sure you get the highest voltage of capacity you have, because if your thing just overdoes it, it might. I haven't been over it, but I haven't seen it broke. Anyway, this here is a coil. This here is the coil we're using. This is actually a ringer for a telephone that the same thing where this keypad come out of. The wingers in that they're almost useless in electronic projects because you need high voltage in order to make a wing. It's because when telephones wing in their signal and the wires, they carry a high voltage alternating current through it to activate the winger. That's how it went. Whenever someone placed a call, send a high voltage AC signal to the telephone's wires, causing it to ring. Now, and that's another reason why that this coil here has high resistance. It's because it's made for higher voltage. It's made for almost house current, except that it probably won't last in house current. It's just that the telephone signals, when they send a signal to ring the phone, it uses high voltage to ring it. That activates the ringer. That's because back in those days, they didn't have very many switching stuff. I think. I'm not for sure. This is what I'm guessing though how it is that they didn't have any switching stuff like transistors and stuff like that could easily cheaply put into the phone. So instead they put a winger in it that would only wing if the voltage is high enough. Anyway, let's get going. I put a stopwatch here. This is a stopwatch that my girlfriend gave me, my fiance, and what it's gonna do is we're gonna measure the time. You see how much time it takes to get up to the maximum voltages. Anyway, right now I have 9 volts going through it. Why to me it says 8? It's because it's going through a diode. The diode is dropping the voltage when it goes through it. And that's why it says 8.6, not 9.1 like the power supply over there says. You'll see why in a few minutes after we get get to the discussion about it. Anyway, let's get going. I'm gonna start the timer now. Get it to not that. Stopwatch. I'm gonna reset it. How do we set? Here we go. Now I'm gonna push start. Push start right there. No, it's mode. It started, okay. Now all you just gotta do is hook this train. It was good. Put this resistor on my to the high voltage to the high voltage pulsing signal. I can't see the watch. There we go. 16, 7. Go ahead. Stops at 28 volts at least. It's 15 volts, 19, 20. Getting close to there. 21, 22, 23, 24, 25, 26, slowing down. 27, getting close to the end. Almost there. 28. It took about 2 minutes and 45 seconds just to reach the highest it can go. Stop this now. Okay, now I'm going to try doing the button. But first, I'm going to discharge the capacitor so it starts off playing. Unhook it first. Unhook it from the function generator. Like that. It'll start losing power. Start going down. It'll not lose it. It'll just go down, start discharging slowly until I discharge it like this. Here we go. Just did it. Okay. Now I'm going to move this meter over here. I'm going to flip this upside, flip it back up. There's our keypad. As I have it wired to the button 4. So if you hit button 4, it will pulse it, as you will see. Anyway, let's get going. Should be going right before. Why is it not going? I bet one of these power wires isn't hooked. Button 4 is over here. I was hitting the wrong button, I think. Right here it is. There we go. I was hitting the wrong button the whole time. There we go. There we go. See how it's going up? Now it's at 12 volts, 13, 14, 15, 16, 17, 18, 19, 20, yeah, I'll stop there. Now I can show you what goes up at 30 volts, but I have to unhook the function generator first. Here it is at 31.2 volts, and I'm gonna starting from that. I'm gonna pulse it through the button 4 on this keypad. You can see how it increases. 40 volts. 42. 'See how high it's gonna go up to 42 volts? Turn this thing on, that's a good thing. It takes a little time. I think that's how high it's gonna go. I'll turn it back down to 9 volts. Maybe 12. Okay, hooked it back up to the function generators. As you see, it's working. It started, now it's at 20 volts. 21. 22, 23, 24, 25, 26, and there we go. I think you got the idea. Okay, now at the drawing board, and here's what we got. We got a boost converter. We got an inductor right there, and it's connected to the switching device. It could be a switch or a transistor or both in parallel if you want to be able to do it without the function generator. Then you can manually do it yourself. Then you got a diode. Any kind of standard diode will work. Same thing with transistor. Any kind of single, depending on the coil, depending on the coil you use, if it's high enough resistance, you can use a small signal transistor to do it. Instead of having to have a power one or a MOSFET. Diode capacitor. The capacitor I use is 100 microfarad at 50 volts. You can use more or less. I don't know what will happen if I do it more. It probably won't go very high. It might have more current capability. It's probably the bigger capacitor, the better current they'll provide out. Anyway, then your voltage out is right between this capacitor here. Across that capacitor is your voltage output. Now, this here is a power source for EB5, 1.5. You can't go too low. Anyway, our signal source, so this will be our function generator, our square wave output, so it looks like a square wave going through a 1K resistor in series with it, so it doesn't break the function generator or doesn't break the transistor, or both, flowing through that, and it goes into the base of there, and our ground of the function generator connects to the ground of this circuit up here too. Now you want to know about charge pumps and how why not use them for it. If you it depends on what you want to do. If you want to get more current, or you want to get more voltage. If you want to get more voltage, the best way to do it is just use a boost converter. If you want to get more current, then use a charge pump. But the thing is, charge pumps they can draw high current from the signal source because of a capacitor. That's only if you use high capacitance values. To get decent current, you'd have to get I'll make a video about charge pumps to go into that. But for right now, I'm just going to talk about the boost converter. Capacitors you can use the low one if you just need like 1 milliamp or so, or maybe 10 or 20 at the most. You can probably use ceramic capacitors that will be without that many high capacitance, and then at that frequency it won't matter because it won't draw that much from the transistor. But this thing here, you can get a coil that can put out a lot of voltage, and it won't draw very much on the switching source, because you got the inductor here with high resistance. It will not draw very much on the transistor. Of course, that might be a way, might be a defect that may make it where that they have a lot of current capability, but that's okay. For a prototype example of just boosting up the voltage is just good enough. The diode here prevents the prevents when the switches pull down. It prevents it from shorting that capacitor out and discharging it, and then not letting it charge up anymore, not holding its charge. That's why they put a diode there. And then when you have the switch is closed, current will go through this inductor and then down to the switch back to this way. When it's open, the current goes to the inductor, diode, and then charges the capacitor. And that's how it works. Now the diode, you should probably get one that's weighted for the voltage you have. At 30 volts providing through it, I don't think I should have did that because these diodes only weight for 50 volts. And so is the capacitor. But it hasn't broke yet, but it doesn't really, it just depends on it if the current's strong enough. If you have a lot of current on it, it could probably break the capacitor or diode. But since it's not that much current, it doesn't really matter. They use boost converters in a calculator. You'll probably look at Wikipedia, you'll see that they used to use a calculator, probably for my calculator. Because I was reading the manual on it, I was looking through the manual, and I noticed to talk about getting a rechargeable battery pack for it. And that's probably what they did, is they used to put the 9 volt, because that boost converter that Wikipedia was showing me had 9 volt battery connector, and that's what the one I have has. And it charges off of, it runs off of 2.4 volts and boosts it up to 9 for the calculator. Of course, the calculator don't draw that much. Well, it draws like 100 milliamps, probably the most of all digits on. That's about it. The frequencies you probably want, you will probably get, I don't know what frequency you want, you have to play around with it. You'll probably find more frequencies different than other frequencies, work better and work worse. You play around with it, you probably figure that out. What frequency will work best with it. And this coil here can be, it could be a transformer coil, it can be a relay, a solenoid, a motor. Anything that has a coil on it will work for it, as long as you use a switching source that can handle the current draw. Mine can do anything because it's limited to real low current when it goes through that coil, because the coil there was made for like a telephone ringer was made for like lots of more voltage than what I'm trying to put into it, and that's why it had a lot more resistance. Because of that, otherwise the coil would get hot and melt and could cause catching fire if it didn't use that higher resistance. Anyway, so then you can put it in parallel. It doesn't matter if it's in parallel with it. If you want to be able to do it, you want to solder into like a button, you want to build the button or the transistor, you can do that. I think I like the idea we can do the button on it, so you don't have to have our function generator to help it bring up the pulsing signal. They also use a boost converter in this here, the solar light. LEDs can't run on just a single AAA battery, so they have to put a boost converter in it, and it's different. This one's different. What I'm thinking is that they put the capacitor inside the chip in it, and capacitor and diode inside that chip there, and then it's just going out to the inductor. But it's weird, it connects onto the LED source. That can't be right. It must be doing something weird. We'll figure out. I want to make a video on to see if we can, how much voltage we can get out of it with different voltages you input into where the battery connects. Then I have to make sure maybe take so you don't want to break the solar cell, you just put a resistor across it so it acts as a load on it, so it knows it's hooked up onto it. and thinks it's off. But that'll be for another video. But your capacitor should be rated for whatever your input voltage is. And diode should be rated for what this voltage over here is. Over here, where you're sitting into it. It should be rated for that. In transistors, switching stuff and stuff like that. If it's not rated for that and it's higher than that, it could possibly break. Make sure you wire your capacitor up in the correct polarity, otherwise you might have some issues. Well, that's it for now. So I hope you enjoyed this video. Thanks for watching. Hope you like it.